All right, welcome to part 2. In this one, you're going to work with matching. So remember, a really good way is to use process of elimination. So here, on this guy, I'm looking for a closed graph pointing to the right. It doesn't even matter. I don't even solve this. I could solve this and be like, all right, x is going to be greater than or equal to 5. So I'm looking for a solution of 5. But I can just look at the graphs. Here I'm looking for open and to the right. Here I'm looking for closed and to the left. And here I'm looking for open and to the left, right? So let's think. This is closed circle and to the left. So which one was closed to the left? Oh, it's that one. So 3x less than or equal to 9. This is closed and to the right. Which one was closed and to the right? This one right here, 2x greater than or equal to 10, right? I could never put like a 2x greater than 10, right? Because it would have to be an open circle. Greater than or equal to makes it closed. So I'm looking for an open circle to the left. That's 4x less than 12. And then obviously open circle to the right, that's 4x greater than 20, right? That one, you might want to write out on a post-it note, like, okay, what are the graphs I'm looking for? All right, on this one, it looks really crazy, like, I don't know what to do, I have a fraction, we don't work with fractions. It's actually super simple. The first thing you're going to do is multiply by 3, right? And then I'm left with 1x, right? Just 1x, right? 1x is greater than 15. So what do I do here? I just divide by 1. So I let x is greater than 15. So my circle here then would, or my graph, excuse me, would look like an open circle at 15 pointed to everything greater or bigger than 15, right? Now, I want to teach you something that is on your homework. So yesterday we were talking about a rewrite flip. That was when the variable was on the right-hand side. So if I had something written like 5 is less than x plus 4, right? I would solve this, and I'd say, okay, plus negative 4, and I would get my answer of 1 is less than x, right? But when I graph this, I would get kind of confused because normally I just go the way the arrow or inequality sign points, right? So I go to 1, and then I would say, all right, open circle, and let's go left. But that would be incorrect, because this is saying 1 is less than x. X has to be bigger, so all numbers bigger than 1. And so that's why we rewrite and flip this. A rewrite flip is you flip these two guys and also flip the sign. So it becomes x is greater than 1. A good way to see this is just read this backwards. X greater than 1. That's what you want to write this way. X greater than 1. We haven't changed it at all. And that's why this looks like this. All right, so that's the rewrite flip. So if I were to do it in this way, 10 is less than or equal to 2x, right? So we divide both sides by 2, divide by both sides by 2, and we get x is less than or equal to 5 with, if I do a rewrite flip on this, because again, the variable, if it's on the right-hand side, I got to rewrite it. X is greater than or equal to 5, right? I just flip-flop those two guys, and I change my inequality sign. Or I read it backwards and then wrote it left to right. There's also a negative flip. So just like when we had a negative variable in equations and we had to end up dividing by -1, when we divide by -1 with inequalities, we also flip the inequality sign. So for instance, if I had negative 4x was greater than or equal to 16. When we solve for an inequality, we solve for x, right? So if I divide by -4, I get x is greater than or equal to -4. But what was this originally saying? This was saying the negative value of x is greater than 16, right? Or equal to 16. But what happens if I say, what about the positive value of x? Well, the positive value is going to be the opposite of the negative value. So I need to flip the inequality sign. All right. In the end, after I divide by negative, I should get x is less than or equal to -4. Right? And what happens when I graph this? It looks like this, right? 0, and here's -4, and closed circle pointed left. And let's just think about this. Here's my original inequality, x greater than or equal to 16, right? What would happen if I plugged in a positive 4 here, right? What would happen if I said, okay, here is my graph. My graph was it should have been pointed this way. Like this is no flip, right? This is wrong, right? Wrong. Make sure you know this is wrong, right? So let's say, all right, plug in a -3, right? Because you're saying that's a solution. With this graph, you're saying anything greater than -4 is a solution. We'll plug in a -3. Well, -3 times -4 is 12. Is 12 greater than or equal to 16? No, that's wrong. Absolutely wrong. So we know we've drawn it the wrong way. Look here. If I plug in -5, right? -4 times -5 is a positive 20. Is 20 greater than or equal to 16? Yes. All right. So I know it's super tricky. It's going to be even trickier when you have to both rewrite flip and do a negative flip. It's like you're going to flip the sign this way, then back this way, and then it's going to end up exactly the same way. That's super complicated and tricky. But just if you can get in your head that when you divide or multiply by a negative, you flip the inequality sign. And if the variable is on the wrong side or the right side, right-hand side, excuse me, of the inequality, you also flip it when you write it left to right. Tough stuff to remember, but super important for getting this stuff right.